Welcome to qnawire.
To determine whether the treatment has a significant effect, you can perform a hypothesis test using a two-tailed test at a significance of 0.05. So in part A, when the population standard deviation is 8 and the sample mean is 54, the population mean is 50, the sample size is 16, and the significance is 0.05. We can calculate the z-score, which is going to be the sample mean minus the population mean over the standard error of the mean, which is sigma over the square root of n. And so it's 54 minus 50 over 8 over the square root of 16, which is 4 over 8 over 4, which is 2, and that's equal to 2. Right. And now we find the critical z-values for a two-tailed test at a significance of 0.05 over 2. This comes from the standard normal table, or the z-table. The critical z is positive and negative 1.96. And since z is greater than our critical z, that would mean we can reject the null hypothesis, meaning the sample mean is sufficient to conclude that the treatment has a significant effect. In B, we'll repeat this, but the difference is that sigma is 12 instead. And so that's 4 over 12 over 4, which is 3. And in this instance, our z is in between the positive and negative critical values, which is not in the rejection region. It is not as extreme, so we would fail to reject the null hypothesis. And that would mean that the sample mean is not sufficient. Which leads us to C, the magnitude of the standard deviation in the population influences the outcome of the hypothesis test. A larger standard deviation results in a larger standard error of the mean, which in turn leads to a wider confidence intervals and less precision. So a larger standard deviation leads to less precision.